We have been seeing in detail how consumers behave, right? That is how they go about optimizing their buying behavior based on their preferences, the price, and their budgets. In this chapter, we will continue this exploration of consumer behavior, but in a more formal manner, which means more graphs and equations. But don't worry, the concepts are just as simple and not at all complicated. Let's make a quick flowchart of the concepts we have learned so far so that they're fresh in our mind as we go forward. We saw that ultimately all choices come down to a simple CBA analysis. The basic question that we tried to answer throughout was, how do consumers decide what to buy? We can call this the buyer's problem. By this buyer's problem, what we mean is how consumers arrive at a choice as to what to purchase, that is, how do they decide their optimum purchase bundle. There are, as we know by now, 3 necessary ingredients required to solve the buyer's problem. 1. What you like, that is, your preferences and your expected utilities from the products. 2. Prices of the goods and services that are of interest to you. 3. How much money you have to spend, that is, your budget line. An optimizing consumer makes decisions at the margin based on these 3 ingredients. What you like, the prices of those things, and how much money you have to spend on those things. Now, of these 3 ingredients, the budget constraint is a given, since it depends on income of the consumer. So taking that for granted, the decision actually comes down to the CBA, right? Now, CBA, as we know, is one key concept. It is in fact one of the key tools of the economic detective. And with the basics of this cost-benefit framework under your belt, you are now in a position to unlock your inner economist and be an economic detective. Someone who uses insights from economics to help make sense of observations from everyday life. And the more of the basic tools of economics you acquire like this, the better you will be at this. So from this chapter onwards, we will start discussing 1 or 2 mysteries in every chapter related to various concepts that we will be studying. Economists use CBA to understand a lot of stuff. The typical term you would hear economists using when analyzing stuff is incentives, which is nothing but the C and the B in CBA. They are positive and negative incentives, right? So people respond to C and B, that is incentives, and make decisions and choices based on these incentives. And we saw in our first chapter that economics is a study of choices, and that is why one of the most central insights in economic analysis is the idea that people respond to these incentives. Indeed, one economist went so far as to suggest that the entire field of economics could be summarized as simply people respond to incentives, with everything else merely being commentary. Quite simply, an incentive is anything that motivates human behavior or encourages an individual to make one decision rather than another. An incentive is something such as the prospect of a punishment or cost or reward or benefit that induces a person to act. An incentive can be money, but it can also be status, an opportunity to save some time, convenience, etc. Let's take up a small mystery here. In a classic 1975 study, economist Sam Peltzman argued, based on solid data, that the newly introduced seatbelt law, when it was first passed, actually increased the number of accidents. Strange, right? How could this be? Today, all cars have seatbelts, but this was not true some 60 to 70 years ago. Back then, hardly any car had seatbelts or security features in general. In 1965, due to public concern over auto safety in the USA, the government responded with laws requiring seatbelts as standard equipment on all new cars. Now, one thing we will see again and again in our case studies is that things very often have direct and indirect consequences. How would a seatbelt law affect auto safety? The direct effect is obvious. When a person wears a seatbelt, the probability of surviving an auto accident rises, which is a good thing, and that is the intended effect of the law. But that is not the end of the story. Because the law also affects behavior by altering incentives. The relevant behavior here is the speed and care with which drivers operate their cars, and this behavior is affected by the decreased probability of harm to themselves. Driving slowly and carefully is costly because it uses the driver's time and energy. When deciding how safely to drive, rational people compare, perhaps unconsciously, the marginal benefit from safer driving to the marginal cost. As a result, they drive more slowly and carefully when the benefit of increased safety is high. For example, when the road conditions are icy, or if you're driving on one of the famous hairpin bend roads of the mountainous states of India. People drive attentively and at lower speeds than they do under normal road conditions. Now consider how a seatbelt law alters a driver's cost-benefit calculation. Seat belts make accidents less costly because they reduce the likelihood of injury or death. In other words, seat belts reduce the benefits of slow and careful driving. People respond to seat belts as they would to an improvement in road conditions by driving faster and less carefully. The result of a seatbelt law, therefore, can be larger number of accidents. According to Peltzman's evidence, these laws did give rise to fewer deaths per accident, but at the same time to more accidents. Seat belts made accidents safer and so accidents increased. Crazy, right? His data showed that the net result was little change in the number of driver deaths and an increase in the number of pedestrian deaths. The decline in safe driving had a clear adverse impact on the poor pedestrians, who were now more likely to find themselves in an accident due to the increased number of less careful drivers on the roads. But they, unlike the drivers, don't have the benefits of added protection, right? When policymakers fail to consider how their policies affect incentives, they often end up facing such unintended consequences. 3 learnings from the small mystery. 1, of course, incentives matter. 2, a non-economic learning. Wear seatbelts, wear helmets, etc. but don't increase the rashness of your driving proportionately. Wear seatbelts and wear helmets, but drive as if you're not. 3, when analyzing any policy, we must consider not only the direct effects, but also the less obvious indirect effects that work through incentives. If the policy changes incentives, it will cause people to alter their behavior. Whether it is Crusoe or an actual real person we are analyzing, they all respond and make decisions based on the incentives of cost and benefit, that is CBA. In all our further mysteries also, these incentives will play an important role. In conclusion, incentives matter, and this will be one of our key tools throughout this course. So let's get back to Crusoe. We left the last chapter with Crusoe having finally figured out his optimal point by matching his indifference curves with his budget line, or as mu equal to P or MB equal to MC, right? But as we saw, the story was not over. That only gave us what Crusoe did that time. Based on his current CBA, he demanded a certain quantity of goods. The word demand has a special and specific meaning in economics. It refers to the quantity of specific goods or services that individuals, taken singly or as a group, will purchase at various possible prices, other things being constant. We can therefore talk about the demand for phones, petrol, ice creams, pizzas, burgers, French fries, laborers, children, even pollution or criminal activities, etc. And of course, milk and eggs. But let's take only eggs now. Remember the buyer's problem? Once the 3 components of the buyer's problem are understood, we can understand demand. Let's bring back the IC curves on the budget line now. Why? Because as we know, the 3 components get resolved at the point where the ICs and the budget line meets, at the point of consumer equilibrium. We saw from a marginal analysis earlier that when the price of X is this much, he purchased these many X. That is Crusoe's demand at that point. We can also derive Crusoe's demand would be at various price points like this. What about if the price of X rises till here? Based on a marginal analysis using ICs and the budget line, Crusoe would now purchase only these many X. And when the price of X rises further, the quantity demanded falls even more to just this much. Similarly, if the price decreases to this point, then your quantity demanded increases till here, right? Let's list out what happens at each price point. This set of combinations is the demand schedule. Now let's plot these in a graph and see. We get a curve. This is the demand curve. This is Crusoe's demand curve or the individual demand curve. We can also see the total demand for eggs as a whole across all customers and not just Crusoe. This would be called the demand for eggs or the market demand. We can actually construct it if we knew all the individual demand curves. But before we look at the market demand curve, let's keep things simple for a while longer. Let's assume Crusoe is the only customer at the supermarket. Let's make everyone else disappear. Now what is the total demand for eggs? It is equal to Crusoe's demand, right? For the rest of this chapter, most of the time we will keep up this assumption and hence keep the market demand curve equal to the individual demand curve. But in some examples, we might have to deviate and talk about the actual market demand. But I'll give you a heads up during those times, okay? Now let's take a step back and see the demand curve once. Do you notice that it's downward sloping? Important to remember this. I like to remember this as demand curve is downward sloping. D. See? Later we'll have to remember that the supply curve is upward sloping. The supply curve is upward sloping is how I remember that. What would happen to this market demand when prices go up? Well, people are likely to buy less eggs then, right? Crusoe also would behave the exact same way. As prices change, Crusoe can move up and down along his demand curve like this. If prices increase, he starts hiking up the curve, buying less and less. If prices decrease, he starts moving down the curve, that is buying more. But why? Let's understand the reasons for why more of a good is purchased when prices fall, that is, why the demand curve slopes downwards. First and most important is the law of diminishing marginal utility. We have learned this already. This is just simple CBA game. Crusoe is just utility maximizing. He seeks to maximize his utility. So when the cost goes up, the utility left comes down and thus the demand comes down. So for every additional unit purchased, the consumer gets less utility and as per CBA will be willing to pay less and less. The second reason is something called the income effect, which basically means that with a rise in price, the real income of consumer is effectively reduced, thus leading to reduction in purchase quantity. We'll see this in more detail in a bit. Next is the substitution effect. If price of eggs rises, it becomes more expensive in relation to other goods, right? So CBA would tell the consumer to buy something else with better surplus or B minus C, such as maybe milk. Again, we'll see substitution effect in more detail in a bit. Next is the size of the consumer group. When price of a commodity rises, less people can afford to buy it, so demand falls. For this, we have to look at market demand curve and not just the individual demand curve. Take the market demand for iPhones. At lower prices, obviously there would be a higher demand for iPhones. But is it because each person buys 10 to 15 iPhones? No. It's because at lower prices, more people can afford it and more people buy it. At higher prices, what would happen? Less people can afford it, so less people buy and hence demand comes down. Fifth and last is the concept of different uses for a good. Many goods may have multiple uses. Milk, for example, can be used in making tea or coffee as well as to make curd, cheese, butter, paneer, etc. If the price of milk rises, people might use it only for their morning and evening coffee or tea. That is, it will be used for the most primary stuff or most high value use only. If the prices are less, it might be used for some more purposes. Same is the case for petrol or diesel. Let's see this case in a demand curve. First, at an individual level, if prices of petrol was less, Crusoe might use it for a lot of things like his office commute, long weekend vacations, visiting friends and family, diesel generators, etc. But if it gets very expensive, he will stop using it for other stuff and use it only for the high value use of going to office or for emergencies only. At a market level, the same principle applies. If oil is in general cheap, society will use it for a variety of purposes, right down to even making petroleum-based plastic toys, etc. But as it gets expensive, we will use it only for high value uses. If it gets really expensive, at a societal level, we might stop using it even for private transport and shift to electric cars and buses and use it only for airplanes, etc., where we don't have other options yet. To illustrate the concept of quantity demanded, think about your own buying behavior once. Think of how electricity is used in your own home. It is used for a variety of things, right? AC, TV, fridge, etc. If electricity gets really expensive, which of these things do you think will get sacrificed? It's a nice way to figure out which are the real high value activities. My guess is that the fridge and TV are likely to be the last things to get sacrificed. We need our food and entertainment, right? But on a more serious note, this thought experiment might actually make us realize which are the wasteful uses of electricity we indulge in and help us conserve some energy and help out our poor planet a bit. This is how people adjust to prices. As petrol prices rise, Crusoe will give up less valued uses of petrol, might start carpooling or shifting to public transportation. And if the prices go too high, he might sell his gas guzzler car altogether. Now let's quantify these kinds of adjustments. And again, we get a demand curve. This time, the demand curve for petrol. So what does a demand curve like this tell us? Willingness to pay and ability to pay are two things that determine demand. This is again based on the three components of the buyer's problem. Ability is determined by the prices and the budget constraint, and willingness by utility. Crusoe's demand curve can be used to calculate how much he is willing and able to pay for an additional gallon of petrol. One extra gallon of petrol is called a marginal gallon. The height of his demand curve at any given quantity is the amount he is willing to pay for that marginal unit of the good. In other words, with 149 gallons already at his disposal in 1 year, Crusoe's willingness to pay for an additional gallon of petrol is $4. Willingness to pay is the highest price that a buyer is willing to pay for an extra unit of a good. So Crusoe is willing to pay only $3 for a marginal gallon of petrol if he already has 199 gallons for use that year, for example. Crusoe's willingness to pay for an additional gallon is negatively related to the quantity that he already has. That is the quantity on the horizontal axis. The more petrol that he already has, the less he is willing to pay for an additional gallon. Now remember the concept of diminishing marginal benefit or diminishing marginal utility. As you consume more of a good, your willingness to pay for an additional unit declines. In fact, you can think of the demand curve as an MU or a marginal benefit curve, tracking the additional benefit derived from consuming one more unit through Crusoe's willingness to pay for the additional unit. So coming back to the curve, at the 150th gallon, for example, Crusoe is willing to pay $4. In other words, with 149 gallons already at his disposal in 1 year, Crusoe's willingness to pay for an additional gallon of petrol was $4. But the actual price of petrol might be something else. It need not be equal to what Crusoe is willing to pay, right? His willingness keeps changing with which unit he is purchasing. But all these units have a constant fixed price, right? So the amount he was willing to pay for the second last or the third last item might not be the same as the price of the last item. Only in the last item purchased is MU equal to P, right? As we studied when we studied the concept of consumer equilibrium. In every previous item, MU is greater than P, and the difference between them is the surplus he makes in every item. It is his B minus C as per the CBA. That is, Crusoe is getting a surplus in every previous item, and we can sum up all these surpluses to get his total surplus from that entire purchase. And this surplus is called consumer surplus in economics. Let's define consumer surplus now. It is the difference between the price the consumer is willing and able to pay for an additional unit of a good and the price the consumer actually pays. For the whole market, it's the sum of the individual consumer surpluses. Let's illustrate this concept one more time. Imagine it's a hot summer day. Temperature is a searing 46 degrees. I decide to drink some cold iced tea. Do you think I would get more consumer surplus from my first glass of iced tea or from my fifth glass? Remember, marginal willingness to pay falls as more is consumed. Suppose I'm willing to pay 100 rupees for the first glass, point A, 80 for the second glass, point B, and 50 for the third glass, point C. And suppose the iced tea is going for rupees 60 per glass. How much consumer surplus will I receive? Notice in this graph that my demand curve for iced tea has a step-like shape. This is because we are treating iced tea as a discrete unit and hence there is no demand for 1.2 or 1.5 glasses. If I want more than one, I have to buy 2. This is demonstrated by my willingness to pay 180 successively for the first 2 glasses of iced teas. Thus, I will receive 40 rupees of consumer surplus for the first glass, 100 minus 60, and 20 rupees of consumer surplus for the second glass, 80 minus 60, for a total consumer surplus of 60, as you can see. Will I be willing to purchase the third glass? No, right? Because my willingness to pay, MU, is less than the price. MU is less than P, 50 rupees versus 60 rupees. So final consumer surplus for me from 2 iced teas, 60 rupees. Because the price was lower than what I was happy to pay anyway. I valued the iced tea more than the amount I had to pay, so I was happy. Graphically, this can be shown like this. The sum of these areas gives me the same consumer surplus number. Now, consumer surplus can also be summed across all the consumers, just like the demand curve. The net gain that a buyer achieves from the purchase of a good is called that buyer's individual consumer surplus. What we learn from this example is that whenever a buyer pays price less than his or her willingness to pay, the buyer achieves some individual consumer surplus. The sum of the individual consumer surpluses achieved by all the buyers of a good is known as the total consumer surplus achieved in the market. Let's say there were some more other people who wanted to drink the iced tea and each had a different willingness to pay for it. If we track all those, we get this table. Now, the total consumer surplus for all of us would be the sum of the individual consumer surpluses achieved by me, Varun, Shalini and Namit. Rupees 40 plus rupees 30 plus rupees 20 plus rupees 10, that is 100 rupees. Why are we not adding Arpit and Sandy here? Because they do not buy the iced tea at a price of rupees 60 and hence receive no consumer surplus. We can represent this graphically as well. The demand curve is again step-shaped with alternating horizontal and vertical segments. Each horizontal segment, each step corresponds to one potential buyer's willingness to pay. In addition to me, Varun, Shalini and Namit will also each buy an iced tea when the price is rupees 60. Like me, they benefit from their purchases, though not as much because they each have a lower willingness to pay. We can also see the consumer surplus gained by Varun, Shalini and Namit. Again, this can be measured by the areas of the appropriate rectangles. Again, Arpit and Sandy, because they do not buy at a price of 60, receive no consumer surplus. The total consumer surplus achieved in this market is just the sum of the individual consumer surpluses achieved by me, Varun, Shalini and Namit. So total consumer surplus is equal to the combined area of the rectangles, the entire shaded area here. Our graph actually illustrates a general principle. The total consumer surplus generated by purchases of a good at a given price is equal to the area below the demand curve but above the price. The same principle applies regardless of the number of consumers. When we consider large markets, this graphical representation of consumer surplus becomes extremely helpful. Consider, for example, the sales of iPads to millions of potential buyers. Each potential buyer has a maximum price that he or she is willing to pay. With so many potential buyers, the demand curve will be smooth, like this. Imagine each point in the graph is one tiny consumer standing there willing to buy that much quantity at that price. Suppose that at a price of $500, a total of 1 million iPads are purchased. How much do consumers gain from being able to buy those 1 million iPads? We could answer that question by calculating the individual consumer surplus of each buyer and then adding those numbers up to arrive at a total. But it is much easier just to look at the graph and use the fact that the total consumer surplus is equal to the shaded area. As in our original example, consumer surplus is equal to the area below the demand curve but above the price. And when prices change, the consumer surpluses also change. Let's say the price of iced tea now changes to rupees 40. Now all these people get a bit more consumer surplus due to this drop shown by the dark blue here, and Arpit since he can also purchase now, he also gets some surplus shown in light blue here. New consumer surplus. Typically, such price decreases increases consumer surplus, since more people can have the products now and more people can have more now. What about in the case of iPhones? What if prices increase? As you can see, the area above the price and below demand reduces. That is, consumer surplus reduces as a result of a price increase.